All right, today we're looking at finding surface area and volume of prisms. All right, remember what a prism is. Prism has polygons on the top and the bottom, congruent polygons as the bases, bottom and the top, and you're connecting those polygons with these lateral faces that are parallelograms. So when we are talking about surface area, this is surface area for any kind of solid, we're talking about the area. If we were to find the area of every face of that solid and add up all those areas together, the surface. Basically, you know, if you were to wrap the Christmas present that is this prism, how much wrapping paper would you need to surround it? You also have lateral area. Lateral area is just the area of the lateral faces. It's like if you needed to paint a room, you're painting the walls of a room, you wouldn't need to paint the ceiling or the floor. That's the lateral face. To find the lateral area of a prism, you take the perimeter of the base, capital P standing for the perimeter of the base, and multiply it by the height. Here we want to find the lateral area of this prism. We're told it is a regular hexagonal prism. Regular meaning that the base is a regular hexagon. So all of these sides of the base are 12. The perimeter, 12 times 6, would give us 72 feet. Well, to find the lateral area, I abbreviate lateral area as LA, not Los Angeles. Lateral area is the perimeter of the base times the height. 72 times 18, 1296. Square feet. We just found lateral area, not counting the area of the bases. We were just finding the area of all the lateral faces. Moving on, surface area of a prism. Well, surface area is the lateral area and then the area of each of the bases. It would be the lateral area we just found plus the area of each base. So find the surface area, and I abbreviate surface area SA, surface area. If we look here, we need to find the surface area of the regular pentagonal prism. Well, we know it's going to be the lateral area plus 2 times the area of each of the base, because the bases are the same here. So the lateral surface area would be the perimeter. This is a pentagon, so the perimeter right here is 25 inches times 7 would be the lateral surface area. And notice we're told this is 3.44. So I could find the area of this little triangle. Look at this. Right there, our pentagon's made up of 1, 2, 3, 4, 5 of those little triangles. And so if I can find the area of that little triangle, I can multiply it by 5 to find the area of this full regular pentagon. So the area of that pentagon is 5 of each of those triangles. Right? 5 times the area of the triangle. The area of that triangle would be 1/2 the base, which is 5, times the height, which is 3.44. So if I multiply that all together, the area of that pentagon comes out to be 43. And that is 43 square inches. Once I multiply or work this all out here, I get total surface area, 25 times 7 plus 43. This comes out to be 218 square inches is the surface area of this regular pentagonal prism. Volume. Volume is actually how much space that an object takes up, not just the area of the outside, but literally how much space it takes up. How many cubes would it take to fill in this solid? So to find the volume of the prism, the area of the base, capital B, is the area of the base times the height. And we are going to look at two types of prisms here. One is called a right prism. A right prism is a prism whose lateral faces are all rectangles and whose lateral edges are perpendicular to the bases. Lateral prism is nice because it's easy to find the height. Think about lateral prism. Think about this being 3D. With the lateral prism, the height is going to be the length of one of those lateral faces. Do you like my shirt? Great. Find the volume of this right prism. Well, notice here that the base on the top and the bottom, this is actually a trapezoid. So remember to find the volume of a prism. It's the area of the base, capital B, the area of the base, times the height. So we need to know the area of that trapezoid. We need to know the area of this base. And the area of a trapezoid is going to be 1/2 base 1 plus base 2 times the height of that trapezoid. And so this comes out to be 1/2 of 20 is 10 times 5 gives us 50. The height is 9, so the volume equals 50 square feet times 9 feet. 50 times 9 is 450. Should have done that in my head. Feet squared times feet is feet cubed. Now we also have oblique prisms. Remember I just talked about right prisms. And now we have an oblique prism. An oblique prism is like you have your right prism standing up straight. Oblique is just leaning over a bit. Now this is a huge idea, all right? I'm going to probably butcher this name, but Capillary's principle says that if we have a right prism and we just lean it over a bit, you know, if you take the same thing, you just shift all of its weight, you know, to your left. Like this, look at this thing, we have a triangular prism. Well, we could have had it standing up straight, but we just have the same height, and we just lean it over, all right? Now, think about like the Leaning Tower of Pisa or whatever. It's kind of the same idea, right? It has the same volume as if it was standing up exactly straight, right? It has the same volume, still takes up the same amount of space. We still need to do the area of the base times the height. That is important. It's still going to have the same volume, it's still the same formula, the area of the base times the height, but not the slanted height. That would be different. We want to still find the height from one base to the next, that altitude. Okay, so here I want to find the volume of this oblique prism shown. Now notice how 11 is information we don't need. This is that slanted height. We don't need that actually, because we have the actual height. The volume of a prism is going to be the area of our base times that actual height. The altitude, it is perpendicular to the base. So the area of our triangle, our base here, half our base times our height, that would be 6 square inches. Our height is 8 inches. The volume comes out to be 48 cubic inches. Okay, all right. So Rick has a gift he needs to wrap. He has 15 square feet of wrapping paper. Does Rick have enough wrapping paper to actually cover this gift? Well, remember, if we're trying to cover a present, I mean, we're trying to cover up the surface area of this present. We need to find the surface area of this box that our gift is in, and we're going to see if he has enough wrapping paper. So remember, to find the surface area of a prism, we're going to find the perimeter of the base. We're going to multiply it times the height. That's our lateral surface area. And then we're going to add 2 times the area of the base, because we actually have 2 bases, one on the bottom, one on the top. So the perimeter of the base, we can see our base is this rectangle, 2 here, 2 here, 3 here, 3 here. So we add all those up. The perimeter of our base is 10, and that is 10 feet, times our height, which is 1 foot, plus 2 times the area of our base. The area of our base, 2 feet times 3 feet, is 6 square feet. 10 feet times 1 foot is 10 square feet. 2 times 6 is 12 square feet. We add these together, 22 square feet. He only has 15 square feet. The poor guy does not have enough wrapping paper to cover this present. He doesn't have it. He's going to have to go buy some more. It's going to cost him some money. That's life.